Welcome back everyone to another Khan Academy tutorial. Today we're going to be doing the aptly named name angles. Now, some of you might think this is super basic and super easy. I'm telling you that this is a very underappreciated skill. A lot of people make silly mistakes. Even honor students make silly mistakes, and it costs them points on multiple choice tests. And even seniors seem to struggle with this concept later on as they don't use this on a day-to-day basis, and they go 2 years without taking geometry. So let's try to really clarify some core issues here and help you to understand this a little bit better. The first question is, which angle refers to the same angle as angle GPB? Now, here's some nomenclature background you need to know. You can always use 3 letters when naming an angle, and that's because you really need 3 points to tell you where an angle is going. If I only have 2 points here, so I'm going to draw 3, so that's an angle. But if I only have 2 points, where's this angle going? I can connect this dot here and make an arrow, but where is this last guy going? Nobody knows. So you need 3 points, and that's why it's perfectly acceptable to use 3 dots there. Now, in an unambiguous situation, let's say we only have an angle here, and we call this DEF because we have 3 points. And let's put some arrows there just to make it look cool. We could actually call this angle E also. So you can either use 3 points, or you can use 1 point when it's not ambiguous which points you're using. I'm going to get into that in a second, which you can call. So which angle refers to the same angle as GPB? So let's take a look here. As you can see, GPB is going to be this one right here. So we have G, P is kind of like the vertex between everything, and then B is here. So if you connect the 3 dots together in order, it has to be in the same order that they say up here. So in order, oops, let's move this up just a pinch, close enough. Then we have GPB, and we know that it is the distance. This measure here is the angle. So we're talking about the blue. So we're talking about letter C. Now, there's a reason why I mentioned this over here, that you can use 1 letter when it's not ambiguous. In this situation, it is ambiguous. We can't just call an angle P. We can't call any of these angles P because that could be referring to this angle, it could be referring to this angle, it could be referring to this angle, it could be referring to this angle, because they all share a vertex of P. When you use 1 letter, it has to be the vertex, so E is the vertex here, but it can't share a vertex with any other angles. So in this first example I gave with E, yes, it's by itself, there's no other vertex it shares, but in this example that we do for the question, my screen is filled now, there was many other angles that shared vertex P, so we need to use 3 letters here, which is why I called it GPB there. So we determined it's C, we check our answer, good to go. All right, moving on. What is a name for the marked angle? So the marked angle is this blue one here. And what lines is it between? An angle technically is the composition of 2 rays. So a ray is 2 points with a line starting at 1 with a definitive start point, and then it goes on infinitely in one direction. Not like the band, but one direction. Okay, now it's 2 rays with the shared vertex. Okay, that's important because now when you're talking about the angle measure, you're talking about this distance between, this measure, I should say, not this distance, this measure between these 2 rays. So there's a ray here, there's a ray here, and it's talking about this blue measure here, okay? And that's that measure. Now, there's a couple different names. We shouldn't use angle A, okay? Even though angle A is the vertex, point A is the vertex, we can't use angle A because which angle is it talking about? Is it talking about this one, this one, this one? Those all have a vertex of A, but you can't call it that. So what we need to do is we need to use 3 letters. Well, we have 3. E, A, and F. And it has to be listed in a specific order. You can't say, oh, I'm just going to put down whatever letters I want, A, E, F. No, it has to be in order. The vertex always needs to be the middle letter. So in this case, A needs to be in the middle. So we could call it EAF because the vertex is A and that's in the middle. Or we could call it FAE because A is in the middle. Both of these are correct. There's my correct check mark. So let's look for EAF or FAE. EAF, there it is. There's no FAE, so we're good to go. A has to be in the middle. Let's check it. All right, here we go. That's a big concept. So if you want to rewind that and watch that again, the angle, the vertex angle needs to be in the middle letter of the three-letter nomenclature. Which angle refers to the same angle as DAC? So let's find DAC. Keep in mind that A needs to be in the middle because it's the middle letter here, and that's our vertex. So we found it there, and now we have DAC. So D is here, C is there. It's situated on two rays, just like all angles are, and that distance is, or that measure is this right here. That's our angle, DAC. So we just need to look for the corresponding picture of DAC, and it's this guy, letter C. Next question. What is a name for the marked angle? We have DA. Whoops, I almost gave it away. First, we want to recognize that the vertex is A. That means A needs to be in the middle. We can't just call it letter A because it's ambiguous. We have all these other angles here that potentially could have A as a vertex. So we're going to identify the two rays that it's situated on with D and C. So we could call it DAC, or we could call it CAD. Both of these are good because, again, our vertex is the middle letter. So let's look for DAC or CAD. DAC or CAD. We see CAD. Good to go. Next question. What angle refers to the same angle as BPF? Okay, let's go a little bit quicker. BPF. It's this little green one right there. BPF. Check it. Next question. What is a name for the marked angle? Can't call it just A, even though that's the vertex. Here's the vertex. So we have E and D. It's got to be called EAD, or we could call it DAE. In this case, it's EAD. That one's the first one I see. EAD, boom. Shakalaka. Which angle refers to the same angle as EDC? Now we have parallel lines here, or seemingly parallel lines. So let's identify our vertex. So we have D, and we still can't call it angle D because there's an angle here and an angle there and an angle there. Okay, there's too many shared angles, but we can call it, EDC. Okay, there's C. C is down here. E is here. It's on two rays that connects them. So we're going to look for this one that has these two green lines, and it looks like it's this guy right there. EAC. Check it. Okay, there you go. Hopefully that cleared some things up for you all, and I hope to see you next time on Wes Explains Best.